Hi everyone, Mr. Neighbor here, and we're going to do some practice problems on mechanical efficiency. So Alice and Jim calculate that they must do 1,800 joules of work to push a piano up a ramp. However, because they must overcome friction also, they actually must do 2,400 joules of work. What is the efficiency of the ramp? So we have our mechanical efficiency equation up here. So the work that they have to do is 2,400 joules of work. And that's only going to give them out 1,800 joules of work. And I must times that by 100. So when I divide these, I will get out 0.75. And then times by 100, I will have 75%. So it is 75% efficient. Not too bad. Here we have another problem. It takes 1,200 joules of work to lift a car high enough to change a tire. How much work must be done by the person operating the jack if the jack is only 25% efficient? So the mechanical efficiency is 25%. We actually need to lift it so that 1,200 joules of work are done. We don't know how much work we have to actually do, though, with this efficiency. So first thing I'll do is divide by 100, which will give me out 0.25 over here. And then I'll have to switch some things around so then I can eventually get the work in as my final answer. So I'm going to flip-flop these. I'm going to multiply the work in over, and I'm going to divide the 0.25 over here. So then it will eventually give me out work in is equal to 1,200 joules divided by 0.25. When I calculate that out, it gives me 4,800 joules that I have to put in to this machine in order to get out that amount of work because it's just not very efficient. However, I'm lifting a very, very big object, so a lot of that energy that I'm using is probably going out as heat. Here we have another problem. A windmill has an efficiency of 35.5%. If a gust of wind does 125 joules of work on the blades of the windmill, how much output work can the windmill do as a result of the gust? So we have 33.5%. Really, I probably can just go ahead and change that to 0.375 right away because I know I have to divide by 100. That equals how much the windmill is going to put in, which is 125 joules. And we want to know, okay, how much work is that going to give us out? So it's telling us how much energy this is going to produce from the windmill. So remember, that's a 3. Let's just multiply this by that. And we will get out about 46.9 joules of work. A heat engine takes 900 joules of heat from a high temperature reservoir and produces 300 joules of work in each cycle. What is its efficiency? So it takes in 900, so that's in the denominator, and produces, that is the out, 300, which will give us 0.33 repeating, and just times that by 100 and we will get 33% approximately efficiency, or 30% if you're using sig figs. An engine that has an efficiency of 25% takes 200 joules of heat during each cycle. Calculate the amount of work this engine performs. So I'm going to change this to 0.25 right away. Forget about that 100. It takes in 200 joules. And how much will it give us out? So 200 times 1/4 would be 50. So it only produces 50 joules of work. An inventor claims to have developed an engine that takes in 1,000 joules of heat and produces 1,500 joules of work during each cycle. Comment on the validity of this claim. Well, we know the efficiency is calculated by taking the input and dividing that by the output work. So the input work is 1,000. The output work is 1,500. And then we times that by 100. And when we do that, we get out 150% efficiency. This is not possible. You can't gain energy. Energy can be transferred, but it can't be just popped out of nowhere. So there was more than 1,000 joules of energy of work being put into the system. So somewhere they didn't calculate something right. They forgot about an energy source to get that input work to 1,000. It really should be more. So they forgot the input source, or they're just lying to us. It's not possible. Unfortunately, if that was, then we would have unlimited energy and that would solve a lot of problems in the world. Alas, that's not possible. So this is an untrue claim. You should question their data. You should question their advertising. You should question what they're building, because it's not possible. Energy, it has to be conserved, which we'll talk about a little bit later. So this, not possible.